In this video, we're computing the integral from 0 to pi of the quantity pi squared minus x squared raised to the 1/2 power. Note that I could have also written this as a square root instead of a power of 1/2. And we're actually told what substitution to make in this integral. It's x equals pi cosine theta. Now this substitution is slightly suboptimal because when we take the differential of it, we end up with a minus sign. If we had subbed in x equals pi sine theta instead, the minus sign issue doesn't appear. But I wrote this problem specifically to give a solution method that was different from Symbolab. So we're going to make the substitution x equals pi cosine theta. And then we have to transform the differential, which means I need the derivative of pi cosine theta times d theta to get dx. The derivative of pi cosine theta is negative pi sine theta d theta. So there's the minus sign that I was talking about. And then the whole point of this substitution is that when we replace x with pi cosine theta, we get pi squared cosine squared theta in those parentheses. We'll be able to factor out a pi squared and use a trig identity. So we're going to take this integral entirely to theta space. I want to transform the limits of integration as well as the integrand. So when x is equal to 0, I plug in 0 into my trig substitution. When x is 0, I get 0 equals pi cosine theta, which means cosine theta is 0, which means theta is pi over 2. And when x is pi, this means pi is pi cosine theta. That means the cosine of theta is equal to 1, which means theta is equal to 0. So we transform the integral. In our lower limit now, instead of 0 is pi over 2. Theta is equal to pi over 2 there. Our upper limit, instead of x equals pi, is theta equals 0. So you can see we're doing kind of a backwards integral here, and I'll address that in a minute. And inside our parentheses, we have pi squared minus pi squared cosine squared theta. This is all raised to the 1/2 power. And then I have my dx, which is negative pi sine theta d theta. We'll get a couple things done on the next line. So one of them is just this minus sign issue. If I pull the negative pi out in front, I recall that reversing the limits of integration produces a minus sign. So I can kill that minus sign by just reversing my limits of integration, and we'll go from 0 to pi over 2. So I'm going to have a pi out in front and an integral from 0 to pi over 2. The other thing I want to deal with is factoring a pi squared out of these parentheses. And that's raised to the 1/2 power, which then gives me just a factor of pi. I can go ahead and pull that out in front of the entire integral and just say there's a pi squared out there. And inside those parentheses, I have a 1 minus cosine squared theta. That's all raised to the 1/2 power. And then we have a sine theta d theta. Now I can use a Pythagorean trig identity on the 1 minus cosine squared. That's just sine squared. And when I raise that to the 1/2 power, that's just another factor of sine. So I have pi squared integral from 0 to pi over 2. And now I have sine theta times sine theta in this integrand. So I have sine squared theta d theta. And this is a classic trig integral. When I see the square of the sine function, I need to use an identity on this. Sine squared is 1/2 times the quantity 1 minus cosine of 2 theta. So there's a 1/2 in front of that identity. I'm going to pull that out in front of the entire integral. So I have pi squared over 2, integral from 0 to pi over 2 of 1 minus cosine of 2 theta d theta. Now each of these pieces is quick to integrate, and I get pi squared over 2, and then I have the antiderivative of 1, which is just theta. And then in my second term, well, the cosine of 2 theta comes from differentiating sine of 2 theta, almost. The chain rule would produce a factor of 2 there, so we put a 1/2 out in front to compensate for that. Now I'm looking at the thing I differentiate to get that cosine 2 theta, so we know we have the correct antiderivative, and I'm evaluating from 0 to pi over 2. Now notice when I sub in the upper limit to the sine of 2 theta piece, that gives me the sine of pi, which is 0. When I sub in the lower limit to that piece, I get sine of 0, which is 0. So that term is gone. When I sub in the lower limit for theta, that also gives me 0. So I don't need to worry about that lower limit at all. The only survivor here is the pi over 2 in the upper limit, replacing theta with pi over 2. And I end up with pi squared over 2 times pi over 2, which we can write as pi cubed over 4, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left. or click the Symbolab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.